Aldehydes and ketones are the simplest functional groups that contain the carbonyl group. The difference between aldehydes and ketones is merely where that carbonyl group is. For an aldehyde, the carbonyl group is always at the end of a chain because that carbonyl carbon must be bonded to a hydrogen, at least one hydrogen. That's the definition of the aldehyde. And for a ketone, that carbonyl group is sort of in the middle. It's never at the end. That carbonyl carbon must be bonded to two other carbon-containing substituents. So let's look at nomenclature for aldehydes and ketones. And like many organic compounds we've already seen, there are some common names as well as IUPAC rules for naming it. The simplest aldehydes usually are called by their common names, which is going to end in aldehyde. So here's some common aldehydes. Formaldehyde has one carbon, acetaldehyde has two carbons, benzaldehyde has the benzene ring bonded to the aldehyde functional group, that carbonyl carbon with a hydrogen. And then our last example here shows the IUPAC nomenclature. So to name an aldehyde in IUPAC standards, we count how many carbons are in the longest chain that contain the aldehyde group. The aldehyde carbon, that carbon with the carbonyl group, is always assigned position of C1. And then once we have identified how many carbons are in the chain, instead of ending in ane like we would for an alkane, the name ends in an al, which stands for the aldehyde. And then we number any branches giving the carbonyl carbon that one position. So we see this molecule has 4 carbons in its longest chain, and so that's butanal. And there's a methyl group off the 3 carbon, so 3-methyl-butanal. Now for ketones, some of them have just a common name like acetone, and that has 3 carbons with the carbonyl group in the middle. And then there's a common nomenclature system where the 2 alkyl groups bonded to the carbonyl group are named from least number of carbons to greater number of carbons. So if we look at this example here, our carbonyl group is bonded to a methyl as well as an ethyl. So this is known as methyl-ethyl ketone. The next one has a methyl and a propyl group bonded to that carbonyl group, so methyl-propyl ketone. Then the IUPAC nomenclature, we count the number of carbons in the longest chain, and then we assign the smallest number possible to the carbonyl carbon, and instead of ending in ane like we would for an alkane, the name ends in one for ketone. So acetone, which has 3 carbons, and the carbonyl on that 2 carbon is known as 2-propanone. Methyl-ethyl ketone, we look at it from IUPAC lens. There are 4 carbons in the chain, and the carbonyl is on the 2, so this is 2 carbons, so this is 2-butanone. And then methyl-propyl ketone has 5 carbons in the chain, and then that carbonyl is on the 2, so in IUPAC, methyl-propyl ketone would be known as 2-pentanone. Now, cyclohexanone has the same name for both IUPAC and common names. If you remember when we named cyclohexane, there was only one substituent off that cyclohexane. We didn't number it. So we don't need a number for cyclohexanone. We assume that this ketone functionality, this carbonyl group, is going to be on the C1.